Hello, good people. This is the last part of 3 videos on exponential and log functions. We're going to start this one with y equals 2 to the x minus 8. So let's make a table of values. Let's start at 0. 2 to the 0 we know is 1, but then we take away 8, so that's negative 7. 2 to the first is 2, take away 8 is going to be negative 6. 2 squared is 4, take away 8 is going to be negative 4. 2 cubed is 8, take away 8, that's going to be 0. 2 to the fourth is 16, take away 8, and that's 8. If we go backwards, 2 to the negative 1 is 1 half, take away 8 is going to be negative 7.5. 2 to the negative 2 is 1/4, take away 8 is going to be negative 7.75, and so on. It's going to get closer to negative 8 there. If I start plotting these points, I've got 0, negative 7, 1, negative 6, 2, negative 4, 3, 0, and 4, 8 is way up there. And you notice they get closer and closer to y equals negative 8, so that's my asymptote. So the graph looks something like that. It goes through that point there. So the domain is still all real numbers. The range now is y is bigger than negative 8, because the asymptote is at y equals negative 8. Remember, this negative 8 shifts the graph down 8 units. So instead of the asymptote being the x-axis, we've shifted down 8 units. The x-intercept is going to be 3, 0, and the y-intercept is 0, negative 7. Let's look at the inverse. Still, to get an inverse, we swap the x and y. So we've got x equals 2 to the y minus 8. Now this one, I can't rewrite this as a logarithm yet because I've got this minus 8 attached on the end. I've got to get that out of there. So let's add 8 to both sides. And I get x plus 8 equals 2 to the y. Now I can write this as a logarithm. It's going to be log base 2 of x plus 8 equals y. And that's the formula for the inverse. And all this other stuff is turned around. So the domain is going to be x is bigger than negative 8. The range is going to be all real numbers. The asymptote is going to be x equals negative 8. So let's graph that one in right now, and then we'll get the intercepts in there. The asymptote is x equals negative 8, so that's over here. So I'm going to draw that dotted line in. Remember, we always draw asymptotes as dashed lines. The x-intercept, if I switch these around, that becomes 0, 3, which is a y-intercept, and this becomes negative 7, 0, which is an x-intercept, so it's negative 7, 0, and the y-intercept is going to be 0, 3. So negative 7, 0 is there, and 0, 3 is up there. And so you can kind of see which way this graph is going once we've got the two intercepts and the asymptote. And the graph is going to look something like this. And again, remember, the two graphs, the original function and its inverse, are always reflections of each other across the line y equals x. If we do talk about end behavior on this one, the original graph has end behavior as x goes to infinity off on the right, y goes to infinity. As x goes to negative infinity off to the left, y goes to negative 8 because it's leveling out. For the inverse, as x goes to infinity, y still goes to infinity because it's heading uphill. As x goes to negative infinity, y does not exist because there's no graph over here, way over on the left side of the graph. But we can talk about as x goes to negative 8 from the right, y goes to negative infinity. Because as x gets closer and closer to negative 8, the y is heading down farther and farther. I hope that helps you understand exponential and logarithmic functions. And I'll talk to you in the next video at some point.